All right, hello everybody. Welcome to lesson 6.6. Once again, this is from the Holt-McDougall Algebra curriculum. In this chapter, in this section, we're going to be learning how to solve systems of linear inequalities. We've been doing equations, things with equal signs. Now we're going to do inequalities, things with greater than, less than, greater than or equal to, and less than or equal to signs. This is our last section in chapter 6, and then we'll be finished with what we need to learn here. And you might notice that, hey, the learning target actually changed. There's a different Common Core standard for this one because it has to do with inequalities. We're kind of focused on this bottom part here, graphing the solution set to a system of linear inequalities in two variables as the intersection of the corresponding half planes, right? In plain English, what that means is we're going to be graphing systems of two inequalities and shading in the region of the solution, right? This area here that says the intersection of corresponding half planes. We're going to be shading in the region of the solution. We're going to do that same thing with three inequalities, and we're going to shade in the region of the solution. So let's go ahead and before we do any kind of solving here, we're going to do a quick review of graphing a linear inequality, because this is a required skill to be able to work with a system of inequalities. So to remind y'all, when we're graphing, we're using this as though it were an equal sign to graph the line. And this is no different than using y equals mx plus b. So we're going to graph that based on y equals mx plus b. And that tells me that I need to have a y-intercept of 2 and a slope of 4, which tells me to go up 4, right 1. That's going to take me off the graph, so I'm going to go the opposite way, down 4, and left 1, because that's the same thing. Now, the difference between an equation and an inequality is you have to remember two things. The two things you have to remember are, is it a dotted line or solid line, right? Dotted or solid. And remember, we base that off of the symbol, okay? Those symbols are dotted. These symbols are solid. And the reason for that is a dotted line is not equal to. A dotted line says, do not include me as solutions. And a solid line is equal to. It means include me as solutions. So for this particular problem that we're doing over here, do we use a dotted line or a solid line? We use a dotted line. So there's my line. Now, the other important thing that we have to remember when we're graphing an inequality is the shading. And it's really important that you understand that the shading equals the solutions. Anywhere where there is shading is the solutions. And it's also important to remember that solutions mean true statements. They are the numbers that create true statements. So what we're looking for is all of the numbers that create true statements. And if you recall, the way that we did that in the chapter was that we would test a point not on the line. I usually pick 0, 0. So we plug it in and we see if it makes a true statement. So this is 0 is less than 2. Is that a true statement? It is. That means that the point 0, 0 is a solution. And that also means that everything on this side of the line will also be a solution. So this would be my solution over here, right? Shading equals solutions. So all of these points that are in the shaded region make solutions. This point right here, not a solution. The point 0, 2, not 0, negative 2. Let's erase it. the 0.02 is not a solution because it's on the line, and remember, dotted lines do not equal solutions. So let's go ahead and do our other example over here. This other example is the same deal. Just remember that we can graph differently. We can solve for y and put it in slope-intercept form, or we can make a table. I'm going to go ahead and I'm going to solve this one for y. So I'm going to add 3x to both sides. That's 2y is greater than or equal to 3x plus 8. Remember, when you are solving, if you're dividing by a negative, make sure you flip your sign. We don't have to do that in this case, but it is something that can happen. So we have 3 halves x plus 4. So I'm going to go ahead and graph that. There's my plus 4. And then I got 3 halves x. That's going to take me up 3, right 2. And then I ask myself, is this a dotted line or a solid line? It's a solid line. And then which side do I shade? I'd better test 0, 0 because it is not on the line, and see if it makes a true statement. Negative 3 times 0 plus 2 times 0 is greater than or equal to 8. That's 0 plus 0 is greater than or equal to 8. So is this a true statement? Is 0 greater than 8? It is not. So that means that this point right here, 0, 0 is false. That means everything on this side will be false. Therefore, everything on this side is true and a solution. Remember, shading equals solutions, right? Solutions are true statements. Every point on this side of the line will make a true statement. So that's my quick review here. I want you to try a couple problems on your own. They're on your canvas, so please switch over and do those 2 problems right now, and we'll do them on the next video.